Hello, everyone. It's now time to discuss the exercises from Lab 2. But before we do that, just a quick recap, right? So we started off with which we thought was an LNK, which was for Kimsuki, and then we were able to verify that. And then later on, we actually had external intelligence stating that it is not just any LNK. There is a specific custom LNK builder that Kimsuki used in order to create or construct their LNK files that they use for intrusions. And a fun fact was this rule which I wrote last year, and it's been a year now, and it's still getting hits on those similar cluster of LNK files. So we're going beyond what we thought that we would initially. We're not just looking at LNKs, but there's an added layer where we are focusing on the builder that is responsible for creating those LNK files. Now it's time to quickly go into some of the questions that we have over here. So just gonna show you guys what the task questions were looking like before moving on to the solution for Kowalski. So the first one over here, can you identify an abnormal characteristic with the file itself? So just gonna quickly go up, grab the file hash and just drop it into VT. So it was the same file hash, the FE156. So it's that one over there. So if you know LNK files, they're shortcut files, and here we can clearly see that the size is so massive. It's 1 MB, which is like bigger than a lot of the executables in our corpus. So that was your first answer over there. Second one, go here. What else can you find that is odd? And check the metadata section. So again, over here, we go to details, head down to the metadata. And here you can see that the creation and the access and the modification date are all 1970, which is quite unusual. So this could be something that is probably exclusive to this LNK file, or it could be probably another side property or like a side artifact that the LNK builder is creating as an unintentional byproduct. Initially, I thought it was set to that exact specific date, 1970, but that was definitely not the case, and I'll talk about it a little bit more. Third one, can you identify any relations to task one? What is contributing to that cause? So why basically the file size is so big? So let's go into our VM. Just gonna quickly open up the terminal. CD, YARA, corpus, malware, Kimsuki. And then if I run strings against our FE156 sample, oh, there we go. So it's actually this whole blob you see, this AAA, which is essentially a lot of padding, and you can see it's existing through majority of the file. So that is very likely that is causing that bloating in file size. Next one, based on the hits from the rule we created, can you tell what is the first and last seen hit? So this is as simple as just rerunning the rule. So what I'm going to do is open a new terminal. I'm going to start VS Code over there. In the meantime, I'm just going to save some time and load our file into imhex because it's related to the next exercise that we have. So, okay. FE156. Again, it's going to prompt for that same hex pattern, the LNK pattern selection, which we talked about earlier. It's going to hit yes this time. Right, in the meantime, that is the rule that we have. Kimsuki_1, that was the rule. So we can just simply run it against our sample again. So for that, we need to go back to the parent directory. YARA rules, Kimsuki, corpus, malware, right? So if we just run the rule against that entire one, this time it's not going to forget that recursive flag. I'm going to wait for that to happen. And naturally, if you recollect, we had hits from our courtesy of APT collection from VX Underground. So you could have just seen the date over there. So it had, because it's organized in years, that's how the yearly archives are available. So here you can see there is March 21st for some of these external references being mentioned. And then we also had another source which we'll see quite shortly, and then followed by a couple of matches in our Kimsuki directory. So for the ones in the Kimsuki directory, you could have simply dropped those samples in Malware Bazaar and then seen when the sample was first submitted, and then you would have figured out your first and last scene based on the rule firing against our corpus. Still loading, so it's probably just going to take some time. And as you can see, first date was March 21st, and this one is March 18. So very neck to neck reporting over there. And the last two matches are for our samples within the Kimsuki subdirectory. So that's the one which we looked at, and that's the additional match. So you could have simply dropped that sample in VirusTotal or Malware Bazaar, and then you would have had your first and last seen dates. Next one, using ARMHEX, load the file and enable the LNK module. Can you spot the link CLSID? This is why we just put that head start. We've already loaded the file over here. Going into the hex editor, just going to maximize over here. So we want the CL SID ID, which is essentially one very particular UUID, and you can clearly see over here. So if I click on that, it selects it. So this could be probably another artifact for us that we could have potentially used in our rules, right? Because you exactly know where that hex string is existing, right? And it's right after your LNK header. So you could have taken the string as a whole, and then you could have selected the offset as whenever the offset is after the LNK header, right? So hopefully you are able to do that if you just wanted to see what is in your corpus that is matching those characteristics. So that was the answer. That was a UUID, as you can see over here. You can say struct type is a GUID, and the specific GUID is called link CLS ID, right? Which is available under the shell link header in the LNK format. Up next, we have create a YARA rule with the GUID alone and test against the sample. So we can quickly do this if required. Otherwise, just to save time, could decide to leave it out as well, but I'm just going to decide to do it. I'm just going to pick this one. Right, just to save time, I'm going to bypass the metadata and other things. Actually, we could have just selected this one, to be honest. So let me just first select the ID as it appears, right? And we know it appears at the offset 04. So we could potentially use that. So this was the rule that we created for our main walkthrough. I'm just gonna strip out some of the properties and then just focus on that one. So let me just do that. Just gonna put GUID over here, right? And then it's gonna select the hex. I just pasted that in. GUID at 4. Hopefully this works, I think. Let's see if it works or not. We just need to change the rule to Kim because that's the file name of our this rule. So if we run it, you can see it's still matching, which means the rule is working as intended. In fact, we see other samples being matched as well, which might be relevant from the looks of it, because I could swear I saw sandworm mentioned somewhere. So as you can see, it's hitting on a number of them. So here we can see, actually, it is picking up some more Kimsuki ones as well. So that was the 0 day that we previously spoke about. And then here you can see some Chinese APT being mentioned as well. I know it's happening a little bit quickly. So if I scroll all the way up, you can see in the LN case also it's matching a number of files, which means it might be a false positive, which might require some refinement, but I'm just going to leave it over there. So just coming to our task 2, which is News Penguin. So I'm just gonna pick on that one. So let's take a look what those questions were. So first of all, naturally, you need the source to answer it as well. So the first one is, what is the significance of the word penguin? Actually, before I mention that, don't confuse News Penguin with your Penguin Toodla, okay? They're completely different groups. In fact, to the best of my knowledge, I think this particular threat actor that BlackBerry mentioned and this particular reporting is the only reporting I could, or only citing I could find on the threat actor itself. I couldn't see any other publicly reported intrusions or campaigns referencing this particular threat actor. It could be for a variety of reasons. It could be probably that OPSEC has matured all of a sudden. Maybe they have just merged into a different group and are being tracked under a different name, or maybe something else. But if you're able to create a rule and if you're able to find evidence in the wild that corresponds to whatever we are using to track this group, it's going to be exclusive intelligence that you're going to have at your disposal, which is going to be pretty cool, I think. Right. So the first one, what is the significance of the word penguin? Simply come here. You can literally see it in the summary. Penguin is actually the XOR key, the encryption key used. So that was hopefully a simple and straightforward question to answer. The second one, create a YARA rule to detect other files at the sample, how many other files you can spot. So let's just go to our VM again. We're just going to create a very quick and dirty rule. Again, I'm just trying to save time so that we can move to our Lab3 later on. So I'm just going to call this News Penguin. Just going to skip all of that. We know that the penguin is used as a string, so I'm just going to do it like that. Before that, I could even just show you what that looks like. So I'm just going to open a new terminal. I'm just going to navigate real quick into the terminal and that directory. So malware, News Penguin. There is only one file. In fact, this is the only file hash I could find, to be honest. So naturally, if you run strings against it, because obviously here I'm making an assumption that penguin would appear in the strings. But if you just did that and then just grep for strings, grep for the word penguin, you should see it's mentioned all over the place. So here all I've done is done pen. Now, something to bear in mind over here, penguin is such a small word that you're better off either using it in the full word operator just to make sure that penguin is not part of some other substring. But in this case, as you can see in the highlighted stuff, like penguin has been mentioned countlessly, right? So what we can do is we can leverage the count functionality in YARA. So I'm just saying instead of the $sign, I'm going to use the hash symbol, which says count the number of occurrences, right? So in this case, hey, count penguin more than, let's say, 75 times, because this will then become like a slightly high fidelity rule that we have. So now going back into our rule, I'm just going to quickly change the rule name. So it's test2 in this case, which is the name of the file where the rule is residing. You run it. We already have a direct match against our News Penguin subdirectory, which was expected, which means the rule is working. Fantastic. So I'm just going to let this run in the background and then we'll move on to the next question. The mid here, run the file command against the sample. What does it read? Can you figure out what is incorrect? So let's just exactly do that. Perfect timing. The run has finished and there's only one match, which is nice. So now going back into our subdirectory where this file is, if I run the file, let me just clear the output. looks a little bit cluttered. And then I'm just going to do file, and then there's only that one file that we have. As you can see over here, it just says data, which is a little bit weird because like previously we have seen LNK files, we have seen Windows PE files as well, but it just says data, which is like a little bit weird. Could it be something to do with the XORed penguin string? So let's try to figure it out, right? Now I'm just going to move to CyberChef just to see what is going on and how we can apply that XOR operation and hopefully see what it turns out to be. It's going to take some time to load. Also, this is running online on the VM, so I haven't installed CyberChef, but it's something if you want, you can do it, provided that CyberChef even installs on a Linux. So yeah, right. I'm just going to delete everything and just going to import that specific file as an input. That's the file. Boom. So as you can see, expected, the penguin stuff is there. But what is more interesting is, as you can see, usually where the MZ or whatever, for whatever matter, the file header is, we don't see something that is recognizable. And this is really why our file command is also saying, we don't know, it's probably just some data or like something else, right? So let's do one thing. Let's try the XOR operation. We know that according to the reporting, that the key is penguin. So I'm just going to select UTF string and just hit penguin, and let's see if that makes any difference. And as you can see over here, the MZ header has magically appeared, which is awesome. And we can see like some other stuff. So what I'm going to do is I'm just going to save this file. I'm just going to call it XOR penguin.exe. Even if you did not put the file extension, it wouldn't make too much of a difference, okay? So it's currently in our download folder. So I'm just going to quickly move it across our subdirectory. Let's do it here, just so that both files are on the same level. Oh, something else. There we go. Okay. So now, when I come to this subdirectory again, we can see there are two files now, our original file and this one. And actually now if I run file against the XORed one, because we already saw that MZ header appear, you can see it now recognizes it as a valid Windows PE executable file, which is fantastic, right? Also, going back to our list of questions, we have already done it. So we figured out there was something to do with the XOR operation. Now, the next one, again, we need to go back to the source. Can you identify another unique identifier that can help us track this threat actor? And it's literally listed right underneath the penguin, and it's very neatly mentioned in bold as well, so you wouldn't miss it, hopefully. So here you can see the get latest news is something that it has been using as a response header, probably during C2 communications, which is highly custom to this particular threat actor, at least from what is being seen here. So we could potentially use it. So something of interest, let me show you something now. So if you actually tried our strings, right, like where we try to grab the penguin, so if we run this against our original one, where we were able to grab for penguin, but if I try this one now, which is get latest news, we don't get any matches. However, if I try this now against our the XORed one, which we saved from CyberChef, hopefully this should match. So get latest news, and you can see it oh, sorry. not string, it's grep. So you can see exactly where that appears. It appears to be some kind of a response header, right? Which is nice. Now, how can we detect this, right? Because that's the final step. That's the hardest one that we have. Create a YARA rule for this. Now, back when I was trying to create a solution for this, I tried to experiment a little bit with what I had available to me, but I quickly hit a dead end, and I'll show you guys why. So just coming back to our rule now, and this time I'm just gonna add, let me just remove it, okay? Let me just put here. Actually, you know what? I'm just gonna keep that the same, and I'm just gonna add an OR condition for the new bit that we have found, just so that we can match against both of those files in that directory. So I'm just gonna call it news. Okay. So now going back into CyberChef, like you could have very easily reverse engineered this. So I could have done something like this, for example, where because we know that the get latest news is an XOR string, you could have just XORed it back and just use the XOR value basically, and then that would be it. YARA does have an XOR string modifier, but unfortunately there is a limit on the length of the byte that you can use. So it only uses 1 byte. And naturally the string penguin is like 7 bytes long, which is why YARA would not be able to use that in the XOR. Otherwise, YARA has a pretty neat XOR functionality. So over here, let me just, because I know I need get latest news, I use the XOR, I hit the penguin. So if you don't convert this into hex, it looks something like this, which is not humanly readable. Not like we can read hex, but that is at least presentation wise, it looks a little bit better. But if you try doing this, right, if you try using this, you should be like, oh, that should work, right? If I run this, right, if I go back, let me just run it against news penguin just to save time. Oops, sorry. I did not reference that string or news, right? So this should have picked up the XORed penguin.exe, which we had. Here you can see the match is only against this one, the first one we had, and that's at the back of this penguin string, which means it's not detecting what we want it to detect. So I literally try to figure out what's wrong with it. I spent some good time on it, and I actually found a solution which works, even though the simple XOR conversion should have worked in the first place. Here you have the XOR operation, right? And actually over here, as we have already figured out using the strings grep functionality on the XOR penguin.exe, right? If I hit get latest, I know it's a little bit small, but just please bear with me. You can see the match over there. And then there it is. So here you can see the match over here. There is a way to kind of circumvent that issue which we had earlier. So let me just show you how you can do that. We're just going to use the 2-hex converter. Okay. And I'm going to use it before the one. Okay, it doesn't work. That's fine. I think we need to load the recipes again. It's probably some glitch. Right. Let me just load that again. As you can see, all it's going to do is take our input file and just convert it into hex. And then actually, if it has captured it, if I click here now, and then I go all the way here, you can see the subsequent bytes being captured. And these are actually the so-called byte that YARA would recognize. So this is your, let me just show you what I mean. This is the XORed version basically, but in hex. But it's not visible because you don't have insights into the where that clear text string looks like. But I'm just going to quickly show you so that we can move on. I'm just going to unselect hex just so that we can get that match again. So here, it's a bit sluggish, which is annoying. Oh yeah, here you have it. So you can see that get latest news, right? All of that, exactly that matches that. So now if I select my hex, we can get the hex equivalent of that XORed representation. So if I do that, and then I unselect my XOR, and now if I very carefully just drag it across all the way until there. So right there, I just need to probably, oh, this is such a sensitive operation, by the way. There we go. So if I very quickly now select, this is very slow, by the way, guys. Not to mention it has scrolled up for some reason. Right there, okay? So if I copy that, now it should work. And again, it is a bit of a weird one because technically that X conversion should have worked, but it's not the case. So if I replace that with the one we found, and I'm just going to make it an and condition this time, just to show you that it's actually going to match against the original sample in opposition to the other sample that we have. So if I run this, you can see it matches. But if had I picked the previous value, the one which we computed, by the way, let me just quickly go back. Crap, I think I messed it up. Essentially the other one wouldn't have worked. Okay, I can just quickly show it to you guys, by the way. This one. If I just quickly select that, just create a rule now. And then run it across. you can see it doesn't work, which means it does require that the value that we have from here. So if I right click and copy that, that's the correct one. I just wanted to kind of show you guys that. But naturally, if you export the file and then run it against that, you don't even need that. You just need the get latest news parameter, and that actually constructs a name for what alias that BlackBerry used. So the get latest news, they pick the news from there, and then the penguin from the XOR bit, and then they had that name. So that is good. I'm just going to show you this one, hex 1 equals, and then that. And then if I just comment that out, you will see it doesn't match anymore. Sorry, it will match this one, but not that one. So you can see it matches, which is a bit of a weird one, but it is what it is. Right, without wasting any further time, we are down to our final lab, which is the boss battle, I would say, which is Whisper in the Wind, where we look at Sidewinder. For here, the human fingerprint is file metadata, and we have a single file hash that we can use. So it starts with 957. It's available in our Sidewinder directory. So let's take a look at this particular file hash. Just gonna first navigate there. So I'm just gonna so over here we can just simply run a file against our 957. You can see it's a docx file, which is your Microsoft Word 2007 plus. This is what we know about it. This is what is there from our initial recon, if you may call it that, right? And yeah, so now this is really where there's going to be a premiere on docx files, and I just want to show you something first. This is really where things get very, very interesting, by the way. So we can see it's a Microsoft Word 2007 plus file, right? And if you actually run xxd against this 957, and let me just take the head just so that I can get the signature, right? So if you run that, you get this 54B0304. And actually, if you cross-reference this, actually we can quickly just do it, right? If I Control F and then just search for that, probably need to put spaces. Probably need to put 4B in caps. Sorry about that. That's a little bit annoying. And then second. So there you have it. So if you just put that file hash in, sorry, the signature in, we can see it matches across our zip files. Then we can also see it matches against another zip, and then docx, which is the most expected one that we have. And here's the queen to F6 move, I guess. Actually, docx files are zip archives, okay? And that's what the file header is really. So if you actually try running like 7-zip against this particular file, so 7-zip, and we're just going to list the contents. I'm not going to extract anything right now. 5957. You can actually see the contents being listed as well. I'm going to just briefly extend that a little bit. Here you can see type zip, the physical size, and here you can see some of the metadata properties. You can see what each element is, as well as what the size is, what the compressed size looks like, and things like that, which is quite interesting. And here, part of your objective for this lab was, our objective was to understand the kind of targeting that they were using. And if you haven't seen document files before, like naturally you will, as you keep traversing through them, you can quickly figure out what is more commonly found in docx files versus other files. The other bit is probably around these images. So I would be interested in images, especially when you're talking about lures and targeting. So why not we start extracting those images and see where we come, right? So now in order to do that, we can just use 7-zip. So initially we listed the file, and this time I'm just going to use extract. I'm going to drop the file in, but we are not going to extract everything. Okay, I'm just going to extract. Let me just put a output folder. I'm just going to call it extracted underscore images. And in this case, we're just going to be extracting anything that ends with a JPEG file extension. And finally, we need to specify the recursive flag because it needs to go through that list of contents, find the images, and then extract those. So hopefully if this command is running as expected, you can see 4 files were extracted because those were the 4 files in the JPEG. So now we can actually hit an ls, and here you can see our directory over here. So let's navigate into it. And oh, it's cascading. So right, so we can see those 4 images, and we can just use FEH, which was installed. So if you hit FEH, or just simply open the file using your file explorer, that's fine. So you can see that there's a file, there's some Arabic, and there appears to be some kind of a very specific event from the looks of it. Right, let's check out image 2. It looks like we're just scrolling down a little bit. So, okay, let's look at image 3. It appears to be some kind of like a Xerox old school style document, and here we can see like there's some stuff going on. There's definitely some kind of agenda that we can glean out of the document alone, right? And this is really where documents are very, very powerful, and they're often ignored when it comes to clustering or attribution, because we tend to focus on some of the mainstream malicious payloads and we leave the documents out quite conveniently. But in reality, if you are able to cluster activities so early on in the kill chain, it provides you more opportunities later on, then, because then you can start using your informed understanding of what you found earlier in the kill chain to then figure out what you are likely to find, like uncover later on. So which is really, really powerful in terms of constructing your hypothesis, right? So this is all good. And you can also just quickly, if we were to take the SHA-256 sum of any of those file hashes, let me just take it for image 1. And if I copy it, just go to VT really, you can see it exists, which means, but yeah, we don't see a lot going on over here, but at least it exists, which means it has some kind of online presence. And naturally, going back into our lab and then just going through this document, I want to highlight something of importance and as to why we are doing what we're about to do next. But before that, a very standard workflow would have been, okay, Yash, so we have these docx files, which are zip archives, and then we're extracting the images, and then we have the hash, and then we can just have this whole pipeline where we do this, and then that way we can then find out those files or documents, to be more specific, that have those embedded images, which is perfectly fine. There is nothing wrong in that. But we can do something a little bit better, right? And over here you can see it's been attributed to Sidewinder, and I'll explain this as well to you. But no one's attributing it to Sidewinder, at least to the best of my knowledge, based on the document alone. Okay, so here you can see there is a contacted URL, which is govtpk.com, which is a very classic domain pattern for Sidewinder. Okay, but moreover, you can see some dropped files, and you see possibly like other LNKs being mentioned, and then people are essentially using those artifacts to track it to Sidewinder. But we have a better, and here also you can see the bundled files, basically the zip contents themselves, especially the images, they are not flagged as malicious. And this is probably where I want to show you guys kind of a premiere around how Office Open XML files work, okay? And what that structure looks like. Because instead of using YARA to get the file header, understand it's a docx file, then dynamically extracting the contents and the embedded images, and then using that to cluster activity, which would then require naturally involvement of some kind of external tool in addition to YARA. I'm going to propose a method that is going to use YARA independently to do this. And it's going to be pretty intriguing because I haven't seen a lot of places or articles mention this kind of analysis, I would say. So before that, we need to understand and have a premiere into what does the file structure looks like, right? So the OpenXML file, as we have clearly seen, it's a type of a zip archive, and it has something which is called the central directory file header. So naturally, if you look at a zip, just by looking at the zip structure, you can't figure out statically what those extracted contents would look like. But the central directory structure essentially lists those contents which are packaged within the zip alongside some metadata properties that we see over here. So starting off with the signature, it's going to have that classic PK signature. So each and every file that is contained within the zip is going to have this structure, right? And then we have versions, flags, compression, mod time and date might be interesting, right? If you remember the Kimsuki one, that first string blob we found, it had like a specific date on it. The CRC32 checksum is very interesting one. And after experimenting a little bit with these properties, I came to a conclusion that the combination of signature, CRC32 checksum, and the file name variable is the perfect combo to track a given embedded file, right, within a zip. So just a caution, the CRC32 checksum is not exactly like your file hash, like how we computed with the SHA-256. It is prone to collisions, but if you were to combine that with the header, with the signature and the file name, as well as the specific offsets, like how we did that in the case of Kimsuki, where we looked at relatives offsets, we can actually nail this perfectly, okay? And let me show you how this can be done. So first, going back into our IAM hex, we're just going to quickly open that file. .957, that one. Just going to close this one. As you can see, that PK header over here, that's the zip header that we had. And typically this central directory structure is located towards the end of the file. Let me go down and let me also show you the subsequent, I guess, output here. So if I did the XXD over here against 957, or actually, even better was the command, the 7-zip command we used to list the file content. So here you can see this is essentially what would constitute as the file name over here, right? Now going back into my IAM hex, at the very end, you can start seeing some of them. So here you can see image 4, image 3, image 2, image 1, and so on, right? Let me just try to see if I can make this a little bit easier to view. So now something worth mentioning, going back to our structure, right? The signature is the PK signature. So now if I come here, let me pick image 3, okay? So image 3 is right here. As you can see, I'm just going to highlight it. Now, this is where it is appearing, right? That's the file name, but the signature is somewhere ahead of that. So let's just take a look at that. And if you look at this, you can see the PK signature over here, which is fantastic. So here, according to the file structure now, this is very, very important. First 4 bytes are your signature, followed by version needed, flags, compression, mod time, mod date. So we know exactly where the CRC32 checksum is going to be in the file. All we need to do is just count, right, after our signature. So 2, 4, 6, 8, 10, 12, right? Because each of them have 2 bytes. So after 12 bytes, after the signature is where the CRC32 checksum is going to be. Awesome. So now if I go back, I can start counting, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which means my next 4 bytes now, this B9, 48, E4, and 17, according to the specification, is my CRC32 checksum. Awesome. So now we have this. I'm just going to quickly copy this somewhere just so that we have some place to store this. Just going to call it sidewind.yara. Right, let's just try to populate this really quick. But before that, I'm just going to save that value here before I forget. And I'm going to call it CRC. Okay. I'm going to leave a place for header as well. You know what? Let me just do it while we are here. Nice. Boom, bada beam. There we go. And now I can populate this really quick. So APT, I think Sidewinder is an Indian APT. So, and while we populate this, I also want to highlight that this is not something that you can just do with images, and it all comes down to your experience. And as you keep looking into the kind of initial access documents that adversaries are using, you will very quickly start to develop a mindset where you're able to recognize those patterns. So this could be done for style sheets being used, different fonts being used, languages being used, how that XML config looks like within the document, maybe some custom footnotes or endnotes, or maybe some emblem that they're sticking on top of the document that might stand out. So there's a plethora of opportunities to do that. Right. So coming back to the naming convention, APT Sidewinder, malware, it's Windows, but I'm going to say it's a document. It might be a loader at this point because it's so early on in the infection chain, but we don't know what type of loader it is. I'm just going to hit unknown over there. And optional artifact will be strings because we're using hex strings. So there we go. And then here I'm just going to put detects documents used by APT Sidewinder. Okay. Could have slapped the file hash in, but just gonna leave it for now. But please, again, we have spoken about this in the main session. Please don't ignore your metadata properties. Very important to build context. Okay. So here now we are the CRC, and now exactly at how many places the CRC is the file name occurring, we need to calculate that. So we already know from signature it's 12. So what I'm going to do is just probably make a rough note that this CRC appears 12 bytes after header. Okay. And likewise, we're going to do the same. It's going to remove this. The next one is your file name. just gonna call it name actually. It's like shorter conventions being used. So, and let's just calculate how far off it is, because you can easily grab it from here, but you need to calculate the distance between the CRC checksum and the name. So let's just see how much it is. So over here, it needs to be 4 plus 4, which is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, plus 4, 26. So after 26, your name should start, right? You can also confirm that, by the way. It's going to be a long counting, so just bear with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And perfect. You can see 77 is the word over here, which means it is pretty correct. So we can just take all of that all the way until, you don't even need the JPEG extension, by the way. You could have just picked here until here. I'm going to copy it across. I'm just going to make a note, 26 bytes after CRC. Okay. And then just going to paste that value in. Now, instead of using relative offsets, how we used in the case of Kimsuki, where we used the @ symbol, and then we had that relative positioning of strings, which we used, I'm going to propose a slightly different method, and this is actually quite easier in my opinion. So we're just going to have a hex. Okay. Now, all you do is simply take that, drop that in, and now I'm just going to use a fixed jump, which is of 12 bytes, as we discussed. Oh, 1 second. Why is it turned red? Oh, I forgot the equal to symbol. Sorry. Right. So now we just paste in the CRC. I already know I pasted in some more characters, so just to get rid of that. There we go. And then after 26 places of the CRC, we have our name. So let's do this. I forgot to place the 3 in, so I'm just going to do it now. I'm just going to comment it out. And then here, all I need to do is just put hex. That's it. Okay. So if I do that and then now run this YARA against our original thing, so let's do that. I'm going to select Sidewinder, and then I'm going to change my name of the YARA rule file, which is going to be Sidewind. It hasn't matched against anything, which is weird. Oh, I've done it again. The same mistake I made during Kimsuki. When I was selecting that, it has left out 77, which is your W basically for word. So I need to put in 77. Okay, hopefully that should fix it. So let's take a look. Yes, we have a match, which is nice. And we have another additional hit, which is even better. Now we can actually try running this against our entire malware corpus and see what hits come back. So just going to wait for it to do that. In the meantime, I'm just going to quickly skim past this. So there are all these technical details in the lab guide, which goes a little bit more into in depth with the whole Office Open XML format, and then some subsequent actions that we have taken at the back of it. Now, I'm going to leave this side quest out for now because it's already 54 minutes. But basically what we try to do in the guide is that instead of, like, naturally here, we picked image image 3, right? Whereas here, what we were trying to do was we were trying to understand how many unique images are there in each of the samples. So if you are interested in this, I can show it to you guys. Otherwise, we're just going to leave it for probably some other time, just to be conscious of the time that we have spent so far. Coming back to our results now, you can clearly see we already had the overlap over here where the Sidewinder directory had those two matches with an additional hit. But now we actually see an external reference being mentioned. So here you can see it mentions it's an article from 2024. It's the same article which says Sidewinder utilizes new infrastructure to target ports and maritime facilities, which is fantastic, right? By the way, those two file hashes are the same across the report, these two basically. But now you have an external reference as well, and you have an additional file hash, which means your rule is doing pretty decent. Naturally, you can experiment with the rule. As I mentioned, you can get rid of the image 3. You could just try it for an image, for example. So instead over here, if you go back into the file hash, we picked up the 3 over here, which is the 33, I want to say. Yeah. So what you could have done was probably strip that out just to see how many of the files have maybe the same checksum, irrespective of the name, right? So we could have very quickly done that just simply by removing 33 over there. And this is exactly what we go in a little bit more depth in side quest. Basically, we try to use the console module, and then we try to do some kung fu with some piping operations where we eventually have a list of all different all different images being referenced in all of the documents that we have, which is quite insightful because then you can clearly see any outliers, right? How many of them don't have the naming convention image X, for example, right? Because where X stands for 1, 2, 3, and so on and so forth, which can naturally open up other opportunities. So now if I run this YARA rule, does it make any difference? Find out. From the looks of it, I don't think it makes any difference. Yeah, it's the same number of matches as before, but yeah, it's always good to experiment, I guess. So that is actually going to conclude our lab, and hopefully you guys found it useful. I haven't seen a lot around using YARA to exactly do this. For external reading, I would highly recommend going through the VirusTotal article on tracking threat actors based on embedded artifacts, where they try to do the same thing, but they try to take the file hash out, and then they did pretty neat statistical comparisons. And they mentioned APTs such as Sidewinder and APT28, which is Russia. I think it's one of the most useful reads if you're really interested in tracking and clustering activities based on documents. So yes, I will catch you some other time. And I would also like to apologize. There was another kind of a bonus lab planned around Cobalt Strike beacons, but unfortunately the beacon extractor is not functioning as expected. So I'm just trying to troubleshoot that issue. So if that is sorted, I will definitely include it. If not, then I will update the lab description at a later point, and then I can show you guys some instructions how you can test it out on your own. So yes, hope that was insightful, and I will catch you guys later.